This is the experimental setup to demonstrate how the aeroplane flies. Here we can control the speed of the aeroplane that is flowing in this wind tunnel. And this is the model of the aeroplane's wing. We can also change the angle of attack here. Up here we can measure the lift force in terms of newtons. And here we can measure the drag force. And this measuring device is connected through this string. We will see the dependence of these forces on the angle of attack. But before that, I will shortly explain how these forces works. When an object moves through a fluid, the fluid exerts a force on this object. This force has two components. One is in the direction of the flow, which is called a drag force. This drag force is a resistive force which is always trying to stop the movement of the object. The strength of this drag force depends on the velocity of the fluid or the object. It also depends on the viscosity of the fluid, and it also depends on the shape of the object. The dependence of the drag force on the shape of the object is demonstrated in another video, and the link is given below. The second component of this force is perpendicular to the flow direction, which is called the lift force. Now the lift force can be upwards or downwards depending on the application. Now the total force depends on the shape of the object and how the pressure is distributed on this object, and it also depends on the angle of attack. At the end of the video, we will change the angle of attack and we will see how the lift force and the drag force is changing. Now this is a model of the aeroplane. If we look at the wing of this aeroplane, we can see that it is designed in a way that the lift force is maximized and the drag force is minimized. So this is the real wing of the aeroplane. It is designed in a way that the angle of attack can be changed. So when the aircraft is trying to land, it is changing the angle of attack in a way that the drag force is maximized so that the plane can stop and the lift force is minimized. And this is the Formula 1 car. The shape of this Formula 1 car is designed in a way that the drag force is minimized and the lift force is downward so that it doesn't fly. Now let's see these forces for the different angle of attacks. So this setup is for the minimum angle of attack, and we can see up there a small lift force and also a small drag force. So both forces are very small for the small angle of attack. Now the angle of attack is increased and the speed of the airflow is the same. And now we will see how the lift force and the drag force is changing. So we can see that the lift force is almost 1 newtons here, so which is much higher than before, and the drag force is also increased. Now it's even more than 1.5 newtons. Now the angle of attack is further increased and the speed of the airflow is same as before. Now we can clearly see that the lift force, which is in the upward direction, is much higher than before, which is around 2 newtons, and the drag force is also increased. We can see that it's even more than 5.5 newtons. Now the air speed is reduced, so we can see the drag force and the lift force is reduced. But if I again increase the airflow, we can see that the lift force and the drag force is again going up. So this is the physics behind this lift force and the drag force, and this is how the aeroplane flies.